Welcome to your video on the power of the media. This video does not actually have much math to it. What it does is looks at conclusions based on data that is presented to you. So what you're going to do is look at each of the 9 examples presented to you. And with each example, a conclusion has been presented. What I want you to do is to think about reasons why that conclusion may not really be very valid. So you're thinking of things that make you go, You want to think, what's wrong with the data? What's wrong with the conclusion? What's wrong with the scenario? Why might I question this data or the way it's been presented or the conclusion that's being made? So come up with as many ideas as you can for each of the 9. If you really try to think before you just watch the video for the answers, it'll be better practice for you. So please try each of the 9 examples, then we will go over them. Then in class the next day, I'll show you other examples that are like the examples presented in the following 9. So please press pause. Please try all 9 examples. Again, you're going to think of what's wrong with the data, what's wrong with the way the data has been presented, what's wrong with the situation, what's wrong with the conclusion. What are things that are making me go, I'm not sure I really agree with what it's saying. All right, so press pause now and try each of the 9 examples. Okay, welcome back to the video. I hope that you really gave each of these a try before you just watch the video for the answer. But the first example was, the following statistics were published in the U.S. News and World Report on February 5th, 2001. It shows the top 3 and bottom 3 airlines that received complaints. Can we conclude that United, American, and Delta are the worst airlines, and Alaska, Southwest, and Continental are the best? So let's see what you said compared to what I said. So the first thing I said is the data is from 2000. So our data is 15 years old. So that is one thing that you have to keep in consideration. The next thing I said is, what are the complaints? How serious are they? Perhaps the complaints for these 3 airlines weren't very serious at all, and maybe these had very serious complaints. So, more people use the top 3 airlines than the bottom 3. So there are more opportunities to have complaints. So these 3 airlines are more popular than those 3 airlines. So it's obvious that if you look at the actual frequency, there's going to be more complaints than those complaints. And we've talked about this in the course before. What we should probably do is use percentages to compare. If you used percentages to compare, on the left here is just the frequency that was presented in the table, and on the right is we looked at complaints per revenue passenger enplanement. So basically it's percent of complaints. So per how many people were on the plane. So it actually shows that United Airlines, American Airlines, and Continental are the top 3, not United, American, and Delta. So when making comparisons, using percentages or what we called relative frequencies should be used instead. So here's our next point. So absolute frequencies, which are the actual numbers, tell a different story than relative frequencies, which are their percentages or rates. Sometimes, rather than doing them just as percentages, you can do them as complaints per 100 passengers. These are better for comparisons when the sample of each strata are not equal. All right, and the last point that I had was a decision would need to be made as to whether it is more appropriate to use absolute or relative frequencies. Sometimes using absolute is more reasonable, sometimes using relative frequencies is more reasonable. So that's what we have to say about example number 1. Example number 2. According to a poll in May 2014, Kathleen Wynne's Liberals should have received 33% of the votes, in a tie with Tim Hudak's PCs. On June 13th, the Liberals won and had a majority. What happened? Were the results of the poll not valid? You can clearly see the poll shows that there was a dead heat between these two, but in actuality, the Liberals won 59 seats, the Tories won 27 seats, and out of 100 ridings, 54 is what's needed for a majority government, so Kathleen Wynne ended up with a majority government. So let's see what you said compared to what I said. So the first thing is, the results go by the number of seats, not the percent of votes. So a higher percentage of votes for the PCs could have come from the same riding. So you'd really want to know the people who were in the poll, which ridings they were in. One problem with polls is that knowing others' opinions may sway yours. Early results may be leading. So for instance, let's say that you really wanted the NDP to win, or even the Green Party, but you can see from the polls that it's a tie between Kathleen Wynne and Tim Hudak. Well, let's say you absolutely did not want Tim Hudak to win. So what you might do is vote for Kathleen Wynne and the Liberals, even though you wanted the NDP or the Green Party, just so that Tim Hudak did not get in. So early results may be leading and may persuade people to vote in a way that they didn't want to. Another thing here is the sample was of 2,000 people, but there are almost 5 million people that voted, which is, so the sample size is only 0.04%. So it's a relatively small sample. Another thing was the vote was 1 month later than the poll. What might have happened in the 1 month? Maybe some dirty material came out about Tim Hudak, or maybe something Kathleen Wynne did or said really persuaded people towards voting for her. One thing is you have to look at the margin of error. We talked about margin of error in a previous lesson. The margin of error right here is plus or minus 2.2%, 19 times out of 20. That means that if these results were valid, then these votes here, 33 minus 2.2 is 30.8, and 33 plus 2.2 could be 35.2. So hers could have ranged anywhere from 30.8 to 35.2, and so could Tim Hudak. So Kathleen Wynne could have been at 35.2, and Tim Hudak could have been at 30.8. So you have to look at the margin of error to see how valid these results are. A smaller margin of error means more valid results. And the last thing I said was not everyone who was polled might have voted. So you might have had people polling who didn't actually vote. So that 33% of people that wanted Tim Hudak might not have actually made it to the voting. All right, the third example, this bar graph shows the amount of money spent weekly by Australian households. Visually, how many more times do they spend on transport than clothing and footwear? So calculate the ratio. So if you take a look at the transport versus the clothing and footwear, it looks to be about, if we actually took a ratio and took a look at the height of this bar, so 1, 2, 3, 4, this bar is almost 4 times as big, and it's also about 2 times as wide. But if you took 193 and divided it by 144, you would not get 8. You would get about 4.4, or let's just say 4.5. So let's see what you said compared to what we said. So the picture is misleading. The size of the bars is not really proportional. So the area of the transport bar, if you actually took a ruler and measured the length and the width of each bar, you would find that the area of the transport bar is approximately 9 times that of the clothing and footwear bar. The actual ratio is about 4.4, which is basically half of what it looks like. So they're misleading you, making it look like it's 9 times as big as this, but it's actually only about 4.4 times as big. So the bar is proportionately high, but should not be as wide. So this bar should have been half as wide, but the height was okay. So you see that in other examples. Here's a graph where it says flu cases are way down. So you can see here from 1990 to 2000, the bars are not equally wide. So what you should be focusing on is the height rather than the width, but people make the width bigger because they want it to make it look much larger than it actually is. All right, here's the next example, number 5. Fox Business displayed a graphic to show the difference between the top tax rate in the George W. Bush era and the new top tax rate starting in January 2013, which was the Barack Obama era. The graph suggests that the tax rate will be 5 times as much. So if you can see here, if you took the height of this bar and if you took the height of this bar, you would think that this is about 5 times as much. So it's showing that tax cuts for Obama is about 5 times as much as the tax cuts for Bush. Did you see the problem though? Did you look at the numbers here? This is 39.6. This is 35. 39.6 is not 5 times as big as 35. So the problem was the y-axis makes the increase look greater than it would if the axis started at 0. The axis here is starting at 34. Anytime you do not start the axis at 0, it makes the difference between the two bars look bigger than it actually is. That is one way that some people will mislead you into thinking that there is a bigger difference. Here's another example. If you start your axis at 0, you can see that there's quite an even number of people who like pizza, hot dogs, and hamburgers. But if you start the axis at 950, there is a much bigger difference, and that is extremely misleading. Here is another example of that type of effect. We are looking here at the statistics for R.A. Dickey, and it was showing in 2012 he had a velocity of 77.3 miles per hour on his knuckleball, and in 2013 it was 75.3. The graph here looks twice as big as the graph here, although it's only a 2 mile per hour difference. So clearly the y-axis was not started at 0, and it makes the effect look bigger than it actually is. So we're going to stop the video here. Please make sure that you watch part 2 of the video so that you can complete the rest of the examples. Make sure you watch part 2. Thanks.